Welcome back, students. So this is revision session for grade 8 advanced for the end of term 1 exams. And today our focus would be the free response questions. We already in the previous video, we have discussed the multiple choice questions according to the coverage document received from the ministry. So we will not waste much time. We'll move ahead. So as you know, the FRQs or the free response questions expected are for 10 each, 10 marks each. It will have like parts, and you are allowed to use calculators as I told you earlier. And the you will get 1.5 hours to do the paper part. So first you are going to do the paper part exam from 9 to 10:30. And then from 10:30 to 11 you will do the electronic. So let's go quickly to our FRQs on our PowerPoint. This PowerPoint will be available to you on your LMS. So as I told you, the FRQs, number of FRQs 4 and marks per FRQ 10. So total 40 marks will be for the paper part. Okay, so in the paper part, let's dive into our FRQ session. So our first question number 21, you know that 20 questions are multiple choice and 4 questions are FRQs. So your first question number 21 will be from the lesson Matter and Thermal Energy. The learning outcome that would be covered would be students will explore kinetic theory and how it connects the arrangement of behavior of atoms, ions, and molecules. So you should know about the kinetic molecular theory. They have given you some practice questions. Based on this, you should know the concept behind these questions so that you can answer any question that is asked. So it says like, what happens to particles when solid turns into a liquid? Why do gases have more kinetic energy than solids? What is thermal expansion? How does it affect material when they are heated? And then a student notices that the metal lid on a glass jar is hard to open after being in the fridge. So describe what happens to the particles in the metal when it is heated. So here again, we're talking about thermal expansion. What does a heating curve tell us about how substances change state? So we are talking about the heating curve, which we have also done in the multiple choice questions. Can you think of material that behaves differently when heated? So here we will be talking about 2 different types of materials which do not follow the heating curve. So let's get into the first question is question number 21A. I have marked it as A, B, C, D, these questions. So question 21A is what happens to particles when a solid turns into a liquid. So when a solid is turning into a liquid, you know that in the solid, the particles are very close to each other. They are packed close to each other. They only vibrate in their places. And when it turns into a liquid, we have to give it thermal energy. We add thermal energy, we heat it. And when we heat it, the particles, they get some energy. The kinetic energy increases. And because of the kinetic energy that increases, they move from their fixed positions. In a solid, they have fixed position. So they overcome these fixed positions. They are close to each other. They are not very far. In a liquid, they are very close, but they don't have fixed position. They're moving a little. So we can explain this by these points. Firstly, there is an increase in kinetic energy. The heat energy added makes the particles vibrate faster. And in a solid particles, they are tightly packed in a fixed arrangement. But when they gain energy, they move freely. In the liquid state, particles are close, but they cannot like move very far away from each other. It's just, they just slide past each other, and so the liquid can flow. So particles, when they melt, particles in solid vibrate in place, but when it melts, they move more freely, but they are staying close together. I hope that makes you understand. And then the next question was, why do gases have more kinetic energy than solids? So this also depends on kinetic energy. Particle movement in solid, they are vibrating in a fixed position. In gases, they are moving freely and their speed is more. They can move in all directions. Kinetic energy comes from, what is kinetic energy? Kinetic energy is the energy due to motion of particles. Since gas particles move faster, obviously they have more energy. The space between the kinetic particles is more, so they don't have a force of attraction which is holding them together between the particles. This allows them to move faster and they gain more kinetic energy. Next question is about thermal expansion. What is thermal expansion? Thermal expansion is the increase in size. When the object is increasing in size, length, area, or volume of a material when it is heated. When it is heated because of thermal expansion. So when it is heated, it expands. It increases in size. That is known as thermal expansion. Why does that happen? When a material is heated, its particles gain kinetic energy. We just studied that. And they vibrate more. These faster moving particles, they push each other slightly further apart, causing the material to expand. So they're pushing each other a little more apart. So the material, it expands. Solids expand in length and volume, example, and that's why you must have studied that railway tracks have gaps. In between the railway tracks, gaps are left. Even in bridges, gaps are left. These gaps are left so that when in summer the heat is more, so they do not bend. To prevent them bending in summer because of thermal expansion, we leave gaps in railway tracks and also in bridges. Sometimes they ask why are gaps there in railway tracks. So to prevent bending due to thermal expansion. Then liquids expand in volume. Like in the thermometer, when you heat a thermometer, you can see the mercury rising up in the stem of the thermometer. So that is expansion in liquid. Gases also expand, um, but they expand more than solids and liquids. If you have a gas in a balloon, you put it in a higher temperature, obviously it will become bigger in size. If you put it inside a fridge, it will reduce in size. So that is thermal expansion by heat. Thermal expansion can cause cracks, bending or pressure. Sometimes, in the sidewalks on the near the roads where there's sidewalks, they yeah, they leave some cracks, like spaces left in between so that it does not crack. So that's why, so that it can expand freely. Then they say that if the lid uh, is like when the bottle is taken out of the fridge, then it is difficult to open the bottle. Why? Because when the metal lid is heat, and then we have to heat it, you put warm water over the lid, it will open. When the metal lid is heated, the particles in the metal, they gain energy and they move faster. As they move faster, they spread slightly, causing thermal expansion. And this thermal expansion of the lid, it makes the bottle open easier, loosens the lid, and it's easy to open the jar. So this is because of thermal expansion we can. Okay, so our next question is a heating curve. This is a heating curve, we already discussed it earlier. Shows how temperature of a substance changes as heat is at. How the temperature is changing as we are adding heat to it uh, over time. So if you see this, it shows a line increasing in temperature and it shows a plateau or a platform where the temperature not increasing, it's like constant. Then again it starts increasing, then again another platform comes when it does not increase, and then again it starts. So these are actually the phases of that substance. Here it is a solid phase, then the solid starts changing into liquid, that is the melting is taking place. And when melting is taking place, at that time the temperature does not change. The temperature does not change. Then again it will, once all the solid has melted into a liquid, then again the temperature will start increasing. And it will keep increasing till it reaches the boiling point. And when it reaches the boiling point, the phase change starts. That is, the liquid starts changing into gas. Now, till all the liquid has changed into gas, the temperature will remain this. And after that, the temperature will start increasing. So at these 3 points, these lines, straight lines going up, these 3 points, temperature is increasing. And at these two platforms, the temperature remains constant. So the platforms are when the state changes, the phase changes, solid to liquid and liquid to gas. So if you are taking an example of water like this, it is solid ice in the form of ice till 0 degree. At 0 degrees Celsius, it will start melting. Temperature will remain constant. Then it starts increasing temperature. It will increase till it reaches 100 degrees. At 100 degrees, which is the boiling point of water, again the temperature becomes constant till all the water has changed into a gas. And then again it starts. So if you go through this, it shows you how the different changes are taking place. So temperature rises in a phase when the substance is only in one state. Temperature increases steadily. Plateaus, or these are platforms or plateaus, they indicate that they are the flat parts of the graph that show that a phase change is taking place, like melting solid is changing to liquid, boiling liquid is changing to gas. Heat energy. Now they ask you a question normally. They say, what happens to the heat energy? Because we are constantly adding heat energy. What happens to the heat energy at this place? Temperature is not increasing, so where is the heat energy going? Temperature is not increasing, so where is the heat energy going? So here, heat energy goes into breaking bonds between particles, and it does not raise temperature. So at these two places, the bonds are breaking. And that's why the solid is changing into liquid, or the liquid is changing into a gas. The curve shows that more energy is required to change state than to just heat the substance within a single state. So it is visually showing both temperature change and phase change, helping us understand. So that's it. Then which are the two substances which do not behave in this manner. So other substances, they show unusual behavior when they are changing state. They do not change like normal water. Amorphous solids and liquid crystals. These are the two. Amorphous solids and liquid crystals. There are two classes. They do not react as we expect them. Glass here, it lacks repeating crystalline structure of solids like it does not have a crystalline structure like ice has. It does not have. So it does not melt at a particular temperature, at a specific temperature. It melts over a range of temperature. It does not have a fixed melting point. That's why it's behaving in a different way. Ice melts at 0 degrees, lead melts at 327, but not all solids have a specific temperature at which they melt. Like a stick of butter, it does not have a melting point. It will become soft and it will melt over a range of temperatures, a range of temperature. Other solids are similar to butter in this way. Instead of having a specific melting point, they soften, they become soft, and gradually turn into a liquid over a temperature range. One of this example is glass. These solids lack crystalline structure, and because they do not have a crystalline structure, we call them amorphous solids. Amorphous solids do not have crystalline structure. And one example of this is glass. Then the other class of substances is liquid crystals. Liquid crystals is another group of materials that do not change states in the usual manner. The ordered geometric arrangement of a solid is lost when the substance goes from a solid state to liquid. Normally it gets lost. There is no arrangement. But in liquid crystals, they start to flow during the melting phase like a liquid, but they do not lose their ordered arrangement. The ordered arrangement remains. So they can retain their geometric order. They do not lose their geometric order. So the example of this is the computing device and electronics such as cell phones. They have liquid crystals in their display. In the display of the mobile phones, tablets, laptops, they have a liquid crystals. So these are the two substances which behave in a different manner. The kinetic theory is very important. You should know the kinetic molecular theory. It has 4 assumptions. These are the 4 assumptions. This tells us how the gases behave. You should know these 4 points. First point says all matter, is composed of tiny particles. It could be atoms, molecules, and ions. Second says these particles are in constant motion, in random constant motion. They're moving. The particles, when they are moving, they collide with each other and with the walls of the container. But the amount of energy that they lose because of the colliding, because of the collisions, that is negligible. It's like very little. So you know what's melting point? It's the temperature at which solid melts into changes into liquid. That temperature is known as melting point. And the energy that it required to change the substance from a solid to liquid is known as heat of fusion. So you should know these two terms. Boiling point is the temperature at which a liquid changes into a gas. That's a boiling point, and the energy needed to change a liquid into gas is known as heat of vaporization. So heat of vaporization and heat of fusion is the amount of energy needed. And point, melting point, boiling point is the temperature. Evaporation and boiling both are like changing of a liquid to gas. They are different because evaporation occurs at the surface. It does not happen throughout the liquid. It happens at the surface and can happen at any temperature. It does not need the boiling point. It can take place at any temperature. They just move to the surface and they have some energy, kinetic energy, so they move out. Then boiling, it is taking place at a particular temperature, and it like boiling happens throughout the liquid, not only at the surface, throughout the liquid, depending on the pressure on the surface of the liquid. Then we come to question number 22, which will be from properties of fluids. You will have to know what is viscosity, why do objects float and others sink, how does pressure affect movement, what happens to the speed of fluid when it flows through the Bernoulli's principle. You have to talk about hydraulic lift and about how to calculate it. So you'll get a calculation problem here. So what is viscosity? It is a measure of fluid's resistance to flow. In simpler terms, you can say how thick it is, how thin is the liquid. Like water is very thin, so it has very less viscosity. Honey is very thick, so it has very high viscosity. High viscosity like honey or syrup, while liquid with low viscosity like water or juice. Why is it important? Because for cooking, oil versus water, frying or mixing ingredients, the thickness affects how ingredients coat foods. They have to cover the food. So if it is like liquidy, obviously it will not cover. So thickness will help in cooking. Syrups and surfaces need the right viscosity for the perfect texture. Then transportation and machinery, engine oils. They should have the right viscosity to lubricate. Health and medicine, blood viscosity affects circulation. High viscosity is not good, it can have health issues. Cough syrups have specific viscosity. Toothpaste, shampoo, they are specific. You can't take a toothpaste which is like very watery. So you need a good viscosity. So it is, this is the same definition of viscosity. Like here you see the syrup, maple syrup, it is slowly falling down because it has high viscosity. And then with temperature, viscosity becomes less. So cold syrup will flow slowly because it has high. If you warm it, then it will become a little watery, it will flow faster. When a container of liquid is tilted, allows it to allow flow to begin. The flowing portion of the liquid transfers energy to the portion of the liquid that is stationary, and so it starts flowing. If the flowing portion of the liquid does not effectively pull the other portion of the liquid into motion, then the liquid has a high viscosity. When it is like going very slow, it means it is high viscosity. Then next question is about what is going to sink and what is going to float. So we know that objects which are less dense than water, they will float in water. If they are more dense than water, they will sink in water. It depends on the density of the liquid. Density is how much mass is packed into, the formula for density is mass per unit volume. If an object is less dense than water, it floats. More dense, it sinks. Wood floats because it is less dense. Metal sinks because it is more dense. Then there's another thing, buoyant force. We already studied about it in the previous video. Water pushes up an object when the buoyant force is equal to or more than the weight or the gravitational force, then the object will float. But if the buoyant force is less than the gravitational force, the object is going to sink. So float means density is less than water. Sink means density is more than water. And what is buoyancy? It is the ability of a fluid to exert an upward pressure on an object that is immersed in it. Why rock sink and rubber balls float in water? Rock sink because the weight of the rock is greater than the buoyant force. Rubber balls float because the buoyant force of water is greater than the weight of the ball. Why steel block sinks but steel ship floats? Because the density of steel ship is lower than that of the steel block, because its volume is more. It is filled with air. If the overall density is less than that of the water, the object is going to float. Next question is about pressure. Pressure applied to a fluid affects its movement because fluids flow from region of high pressure to a region of low pressure. So they transmit pressure. Pressure can be transmitted. When you are squeezing a toothpaste at the back, the paste comes out from the front because the pressure is transmitted. Fluids cannot resist shape change, so when pressure is applied, it is transmitted in all directions. This is Pascal's principle. Squeezing a toothpaste pushes toothpaste out of it evenly. Hydraulic system is again another use of Pascal's principle. It uses pressure to move fluids. You can do more work applying less pressure. Pressure differences cause flow. Fluids naturally from high to low pressure. The greater the pressure difference, the faster the fluids flow. Then it has an effect. Water flows from tap because the water inside the pipe is under high pressure than the outside. Wind forms because air moves from high to low pressure. Pressure can also control how fast or in which direction a fluid is moving. Narrowing a pipe will increase the speed. That is Bernoulli's principle. What is Bernoulli's principle? When a fluid flows through a narrow space, its speed increases. Like here, when it is flowing through narrow space, its speed will become more. And when speed increases, the pressure will decrease. Water in a garden hose flows faster when you partially cover the opening with your thumb. Sometimes we cover it with the thumb, its speed becomes more. Rivers speed up when they flow through narrow valleys. Relation to pressure, according to Bernoulli's principle, as the speed of a fluid increases in a narrow space, the pressure, it has a inverse relationship. Speed increases, pressure decreases. Narrow will go faster, wide will go slower. Here, this is the hose and sprayer. Here, see, the speed is more. What is moving through this speed is more. And when speed is more, density is less. Sorry, pressure is less. And when pressure is less here pressure is more because it's like the air is in here, there is air. So since pressure here is more and here it becomes less, so the liquid moves from high pressure to low pressure. It creates a low pressure and the chemicals move up and they get mixed with water and they spray out of the tip. Describe how the pressure changes as the velocity of a fluid increases. Velocity increases, pressure decreases. How Bernoulli's principle makes the hose, and I just told you how it will operate. Then hydraulic lift. This is Pascal's principle. Like we can lift cars for washing, etc., for repair. We lift cars by applying a little force. When pressure is applied to a fluid in a confined space, when we are applying pressure in a closed space, it is transmitted equally in all directions. This means a small force is applied on a small piston. Small force on a small piston and it can create large force on a bigger piston. So we are applying less force and we are lifting heavy objects. A hydraulic lift has two connected pistons of different sizes. One is small and the other is big. And they are filled with a hydraulic fluid. So when we push the small piston with small force, the fluid transmits the pressure to the large piston. And the large piston exerts greater pressure, upward force, and that lifts a heavy car. So it is useful because we can lift heavy objects and we don't require too much force. And it is safe and smooth because the fluid spreads the force even. This is the hydraulic lift is working on Pascal's principle. Small piston, large piston. We apply small force, it gets transmitted through the fluid and the large piston goes up. So this you should know, the pressure pressure is equal to force divided by area. So the pressure which we apply here, it will pass through this and it will be equal to the pressure which we get here. Okay, so in pressure in should be equal to pressure out. Pressure is what? Force over area. So input force over input area will be equal to output force over output area. Force is always, unit is Newton and area is square meter. So Fn, we write in for input and out for output. So Fn over An is equal to F out over A out. Hydraulic lifts work on this on this principle in auto repair shops, etc. So you can get a problem to solve using this formula. Like here, calculate a hydraulic lift is used to lift a heavy machine that is pushing down on a 2.8. So heavy machine is pushing down and you have to lift it. With the force, this is the 3000 cm. This is the force of the heavy machine. That means this is the output. And this is the output area. What force must be exerted on this piston which has this area to lift the heavy machine? You have to find the force in. So first you write what has been given to you, note it down. Fn is not given to us. F out is given, A out is given, and A in. And then you write the formula. Please, girls, remember in your paper part, you need to write the formula. There are marks for the formula. You need to write the units. There are marks for the unit. If you will forget to write the unit, unnecessarily, some mark would be deducted. So Fn equals to, they have changed the formula accordingly. You remove the A from here. When you remove the A from here, you will multiply this side. F out over A out equals multiplied by A in. Plug in the values, use your calculator and find the answer. A heavy crate applies a force of 1500 newtons on this. The smaller piston is 1/30th size of the larger one. What force is needed to lift the crate? So first is the pressure, force over area, pressure of the heavy crate. This is the pressure of the heavy crate, force over, you can write it as F out and A out, and then F in and A in. They're saying calculate the force needed on the small piston. So you will compute the value because this is 1/30th. 1/30th of it. So that's why we are dividing it by 30. Then come to the next question. It is from the lesson composition of matter. These are the questions which you should know. This is relatively easy. An element, what is an element? It is a pure substance. It is made up of only one type of atoms. Element is made up of only one type of atom. You cannot break it down into simple substances by chemical means. Element is the simplest. Each element has its own unique properties and all known elements are listed on the periodic table. So we have the periodic table which has all the elements which you know. Now they want you to know the elements, some elements. So here they've given you some examples. These are elements: oxygen, carbon, gold, hydrogen. These are elements. Then what are the uses? Here say what are the application of these elements: copper, silver, lead. So you should know what are they used for. Some examples are from your book. Silicon, it is used in the silicon dioxide is used to make window glass for the glass, and silicon chips that run computers. So in glass and computer chips. Then americium, it is synthetic radioactive element. It is used for smoke detectors. Then we have titanium. It is a strong and lightweight element, and it is used for bone and joint replacement, like in the medical field for replacement of bones and joints, and also in the aircraft construction. They use also in sometimes it is also used in panel constructions. Then magnesium is found in chlorophyll. Magnesium is found in chlorophyll, the substance that makes the plants green. In one of the questions, they asked you what is magnesium found. Chlorophyll, it makes it green, used in the metal mixtures. Magnesium is lightweight, strong, and resistant to corrosion. Because of this, it is used in jet engines. So you should know at least the uses of these elements. Copper is used for wiring, cables, conducts electricity, plumbing pipe, coins. Silver is used for jewelry, silverware, electrical conductors, etc. Also in photographic films and mirrors, we use silver. Lead is used in car batteries. It is used for shielding us from X-ray. X-ray, like you have to wear those lead, like those aprons with that lead sheets in it, so that X-ray does not harm you. Aluminium is aircraft and automobile because it's lightweight and strong. We use foil for packing materials. Cans are used in kitchen. Silicon, I already told you, computer chips. Americium, I already told you, smoke detector. Titanium, this I have already told you. So please go through this slide and remember the uses of these elements. Then what are the other applications? Lead is important element due to its high density. This thing which we wear when we go for an X-ray, it has lead. So because it has high density, it does not allow the X-ray to pass through it. And because of this, we wear it in order to protect the rest of our body from X-ray exposure. For aprons for use in dental X-rays are being taken here. Aluminium is bendable and resistant to corrosion. It is nowadays becoming. Alexa, stop. So world's most widely used elements. It is strong and lightweight, used in automobile parts, airplanes, bicycles, pots and pans. Then what is a compound? Compound is a substance made of two or more elements chemically combined in a fixed ratio. Two or more elements chemically combined in a fixed ratio. They lose their properties when they are forming a compound, like water. It has hydrogen and oxygen. Hydrogen has different properties. Oxygen has different properties, and water has entirely different properties. So when a compound is formed, it loses its properties. The individual elements, they lose their properties. Sodium chloride is made up of sodium and chlorine. Na is sodium, Cl is chlorine. Then what is a mixture? Mixture is also made up of two or more substances, but they are physically combined. Here they were chemically combined, physically combined, not chemically. The substances keep their properties. They are not losing their properties like in compounds, like sand and salt when you mix them together. Salad dressings, fruit salad, etc. These are difference between compound and mixture. Composition of elements it's fixed, it is not fixed. Properties are different from those of the element. It shows the properties of all the elements. They can be separated by chemical methods only. They can be separated by physical. It's always homogeneous, but this can be homogeneous or heterogeneous. Here, this figure is showing you this is a mixture. How do you know this is a mixture? See, it has two different types of particles. They're mixed together, not chemically combined. Element, all particles same. Compound, it has all particles same, but each particle has two different type of elements. Two different types of elements. So this is mixture, element and compound. Substance in which atoms of this I just told you, like this is chlorine gas, this is sodium metal. When they combine, they're forming salt. Entirely different properties. Mixtures can be heterogeneous and what are heterogeneous mixtures? In salad dressings made with oil, vinegar, spices, all of the items in the dressing are in contact, but they do not react with one another. If you leave it undisturbed for some time, it is going to settle down. And you can make out it's not uniformly distributed. So that is a heterogeneous mixture. So you can say heterogeneous mixture in which different materials remain distinct. You can see them distinctly. That's a heterogeneous mixture. Like dressing salad, vegetables in a salad are distinct. Now, heterogeneous mixtures can be two types, suspension and colloid. Suspension is also a heterogeneous mixture, but if you leave it undisturbed for some time, like mud and water, it is going to settle down. It will settle down at the bottom of the container if you leave it undisturbed. Like in the river delta, the mud settles down. Rivers flow swiftly through narrow channels, but when they come to wide channels, this flows slowly and the mud settles down. This is suspension. Colloid is a heterogeneous mixture, but it does not settle. It remains in solution. It does not settle. It contains water, fats, and proteins like milk, but it does not settle. It is a heterogeneous mixture which particles never settle. Paint is a colloid. Fog is colloid. Blood is colloid. Smoke is colloid. These are examples of colloids. Homogeneous mixtures. They are like uniformly mixed, and the particles are so small that they cannot be seen even with the microscope. And we also give them another name. We call them solutions. Compounds and homogeneous mixtures are made up of more than one element and are same throughout. Compounds must be made from elements in the exact fixed ratio, but mixtures can have different ratio. A soft drink, this is important, a soft drink can either be heterogeneous or homogeneous. So if it is a flat soft drink, it will be homogeneous. But if it is a fizzing out soft drink in which the gas is coming out, carbon dioxide, if it's out, soft drink is heterogeneous. The resulting flat soft drink is homogeneous. So remember, when it is fizzing, when the carbon dioxide is coming out, it's heterogeneous because you can see carbon dioxide. But once it becomes flat, then it is a homogeneous soft drink. So here they have described difference between colloid solutions and suspensions. In colloids, particles are larger than solutions. They are very small to see even with a microscope. Here they are large crystals visible and they are seen in the mixture. But over time they can settle down. Like here you can see the particle. After some time they are going to settle down. Appearance may appear clear or cloudy. It can be clear or it can also appear cloudy. But it scatters light. This is important. It scatters light. Solutions do not scatter light. They're clear, do not scatter light. You can see particles cloudy or muddy in appearance here. Example of colloids: milk, paint, smoke, blood also. Suspension: pulpy orange juice, salad dressing, mud and water. Solutions: perfume, tea, vinegar. These are some examples. How are elements and compounds related? Both are types of substances. Elements have atoms that are all alike, but compounds are made up of two or more elements chemically combined in a fixed ratio. Three elements and three compounds. You have to give examples. So here they say copper, oxygen, zinc, titanium, lead, they are elements. Water, chalk, salt, they are compounds. Elements and compounds are both substances made up of atoms. In elements, the atoms are of the same type. In compound, they are of different type, but they are combined in a fixed ratio. Now, how do we identify a colloid from a solution? This is a solution, this is a colloid. When we pass a beam of light through it, we can see the scattering of light. We can see the path of light in a colloid, but not in a solution. So this is known as the Tyndall effect. It is scattering of light by tiny particles that makes a beam of light visible. It occurs in colloids, not in solutions. Why it happens? Because the particles are big enough to scatter light. Like sunlight, when you see sunlight coming through a dusty room or in a forest, you can see the sunlight coming. That is because of scattering of light. Headlights visible in fog. When there is fog, you can see the light beam. Flashlight beam in a glass of milk. So if you see a mixture in light in a mixture, you know that it is Tyndall effect. So this is the definition of, you can go through this table. Differences between homogeneous and heterogeneous. We just went through it. Composition, appearance, example, and how we can separate them. So here they have summarized it. Matter can be two types: pure substance and mixture. Pure substance are elements and compounds. They can change. Elements can make compounds. From compounds we can get back elements by the chemical changes. Element example: oxygen, gold, iron. Here compound: salt, baking soda. Mixtures can be homogeneous and heterogeneous. Heterogeneous mixture: dirt, blood, milk. Homogeneous: lemonade, gasoline. Homogeneous mixtures are also called solutions. Then next question is from the lesson periodic table. What are the main parts of the atom? Where are they located? Okay. So an atom has three main parts: proton, neutron, and electron. Proton are positively charged, +1 charge. Negative charge, -1 charge. Neutron is neutral. Where are they found? In the nucleus. Protons and neutrons in the nucleus, and electrons in the electron cloud or in the energy levels. What is the function? It determines the atomic number. Proton determines the atomic number. Neutron added with proton gives you the mass. And this electron is involved in chemical bonding and in electricity. Here some elements are given to you, some names are given and where they are found. Like C is for carbon, calcium, Ca, gold, Au, Al, aluminium. Common ones you should remember: H, hydrogen, Cl, chlorine, oxygen. Carbon is found in all living things, in coal, graphite. Calcium is important for bones and teeth, used in cement. Gold is precious metal used in jewelry. Aluminium is lightweight, used for foils, cans, airplanes. Hydrogen is lightest element, found in water. Chlorine is used to disinfect and purify water. Oxygen for breathing and to burn substance. Now, difference between Bohr model and the electron cloud model. This is Bohr model in 1930. Niels Bohr gave this model, and he says that the electrons are moving around the nucleus in fixed energy levels, and these are orbits, the fixed orbits, and if the electron has to move from one orbit to another, it will either absorb energy or it will release energy. Electron cloud says that the new electrons are moving in an area. It does not say in this, in an area, and we cannot tell at what time where it is moving. So the electron cloud model states that there is an area around the nucleus of an atom where the electrons can be found. Bohr says that fixed orbits around the nucleus. That's the main difference. Now, in the modern periodic table, there are periods and groups. The horizontal rows are called periods and the vertical columns are called groups. Periods are from 1 to 7 and groups are from 1 to 18. They share similar properties. Groups share similar properties, and periods have, like, the atomic number increases from 1 to 7 as you move in a period. In the periodic table, we have these cards like this for every element. This is the atomic number, that is the number of protons. O is the symbol, the name of the element, and atomic mass. So each box shows this information in a periodic table. Then you have to remember this, that the energy levels, electrons move in energy levels, and there is a fixed number of electrons which can move in these energy levels. Like in the first energy level, only 2 electrons maximum. Second, 8. In third, 18. In fourth, 32. So that way they keep on increasing energy levels. And as you move from the nucleus outwards, the energy also increases. So the one in the first orbit, this has the lowest energy, and the one outest has the most energy. But then you have to remember, in an atom, there is another condition, that outermost energy level should have a maximum of 8 electrons. Not then only that atom will be stable. Otherwise, it will not be stable. If it is the first energy level, the maximum number will be 2. Here there are only 2 elements, hydrogen and helium. These outermost electrons, they are called the valence electrons. Valence electrons determine how an element will be. Is it going to be reactive, unreactive? That depends on the valence electrons. Since elements in the same group have the same valence, same group, same valence electrons. So that's why the properties are similar. Group 1 have 1 valence electron. Group 17 has 7 valence electrons. Now group 1 has 1, so it will react more with group 17 because it can give away 1 electron to group 17. If there is a full outer shell, it will be stable. Now the elements, they react with each other to acquire stability, to see that they have a full outer shell. And there is one group of elements, group 18, which is called the noble gases. They have a fixed or a full outer energy level or shell. That's why they are the most stable. Like helium, it has full energy level 2. Neon 8, argon 8, these are the valence, only the outermost orbit. This is the electron dot diagram. Kryptons and all have 8. So they are very, very stable elements. They are non-reactive. They are not reactive at all. They don't easily form compounds. They exist in single atoms. So every element wants to become like a noble gas. And for that, it means it wants to acquire 8 electrons in its And that is the reason why it reacts. This has changed. This has been updated. Describe how metals, metalloids, and they are arranged in the periodic table. You know, metals are found on the left side. This side, left side, metals in the center, left hand center. They are usually shiny. These are the properties. Shiny, good conductors of heat and electricity, and malleable. That means they can form sheets. They are also ductile, that is, they can form wires. Non-metals on the right side, except hydrogen, they are usually dull, they're poor conductors, and room temperature. At room temperature, most of them are gases. Metalloids are found in a zigzag staircase line between the metals and non-metals. They have properties of both metals and non-metals, and they act as semiconductors. They act as semiconductors here. The blue are the metals, all metal you can see left and middle. On, and in the right side are non-metals, and here you see that zigzag type. So these are the metalloids. So that's all in your FRQs. I hope you're going to do well. You will ace your exam. Keep your confidence. Read your questions very, very carefully. Once and twice. See what has been asked, then answer your question. Sometimes you read the first part and you just omit the second. Read it very carefully. Are there two questions asked in the same thing? And when you are answering, see that you write everything you know about that particular question. If you are you doing some calculations? Don't forget to write the unit, use your calculator, recheck your answers, and inshallah, you're going to be very good. You will be excellent. Good luck from my side. Do well. And I want you coming out of your exam hall with smiling faces. Good luck, dear students. Aliza!